Okay, next topic 5, arithmetic and geometric series. So for these ones, we've got formulas that we're going to write across the top here for the sum of a series up to a certain number. So S sub n, we've got n, and then the first term plus the last term divided by 2. The sum of a geometric series, we've got the first term, 1 minus the common ratio to the nth power, and then divided by 1 minus r. And the sum of a convergent infinite geometric series, that means you just, in theory, keep adding them forever and ever and ever and ever, without actually ending anywhere. You only do this if the ratio is a fraction, smaller than 1, and then that would be this formula. Okay, so we've got a bunch of different formulas that we can use here. Find the indicated sum for each series. That means you first need to figure out if it's arithmetic or geometric. So this one, you can see it's arithmetic. It's going down by 5 each time. So if you figure out what the common ratio is, then you can just sub in and figure out each one of your values. All right, so you can kind of work backwards and figure out what the 22nd value would be. So we've got our common ratio, which has turned out to be a -5. You can use that common ratio to figure out what the 22nd term is. Okay, so we just sub that in. That formula will give us the 22nd term. So we have -5 times 21 plus 6 is -99. So -99 is the last value in this sum. So sum all the way up to 22 is n, the number, in parentheses, the first term plus the last term divided by 2. Okay, you can just sub that value in. So we have 22 times 6 minus 99 over 2. That is -1023. Okay, this one, definitely not arithmetic. If you look for a common ratio, this is divided by 6, 6, 6. So this is geometric, and the ratio is 6. So we're going up to the 15th right here, so we can use this formula. So S sub 15, we've got A sub 1, so that's 2, times 1 minus r to the nth divided by 1 minus r. And that can just get subbed right in. Very large number. Let's see, 18807399383. Okay, 3, 3, 3. There we go. Okay, number 40. You look here. This must be geometric because the signs alternate, and it looks like you're dividing by a -4. So the common ratio would be a -1/4. That's what you multiply each time. So same formula we've got up here. So we've got S sub 8 is the leading term, 1 minus the ratio to the nth over 1 minus the ratio. Okay, so we get this lovely value, or if we wanted it in decimal form, we get about this, 639.99. Okay, this next one, definitely arithmetic. You can see it's just going up by 2 each time. So the common difference is 2. We can use the common difference to figure out the 36th term. So the 36th term, we have the common difference times n minus 1 plus the starting value. Okay, so the 36th term would be 41. And then knowing that, you can sub into this formula. So the 36th sum is, we've got n, which is 36, times the first term plus the last term divided by 2. And that can just get subbed right in. Okay, and we end up with 216. Okay, next, so this one is definitely geometric. You can tell by the way that it's laid out here, and we can figure out all the missing pieces. So definitely geometric. From here, we can gather that A1 is a -2, R is a -3, and then the n that we're looking for from 1 to 9 would be 9. So those values just get subbed into the very same formula. So S sub n is A sub 1 times 1 minus R to the nth over 1 minus R. Okay, so we get this, negative 9,842. Okay, this one, not geometric, that's for sure. It looks like you've got something that's more arithmetic. So you can kind of work your way backwards there. Okay, so we can plug in and figure out what the A1 would be. So if we subbed 1 in here, we have 4 times 1 minus 7, which gives us -3. And then we can figure out what the 24th term is by subbing that in as well. And remember, for these, the arithmetic ones, you don't even actually need D in this formula, so you don't have to figure that out. We just need the first and the last and the number. So we're going up to 24, so that means we need to know the 24th term, which that can just get subbed right in there as well. So 4 times 24 is 96, and then minus 7 would be an 89. And of course, the number is 24. So the 24th sum, we have an n on the outside, and then in parentheses, the first term plus the last term divided by 2. That's the formula we have in the upper left. Okay, we get 1,032. Okay, 44, back to being geometric. So this one, these are a little bit trickier, the ones that don't start at 1, but we can still kind of work our way and figure out what the A1 would be. So you kind of trace backwards, knowing that this is 1/2. So if the third term is 64, multiply that by 2, divide that by 2 to kind of work our way backwards. We can figure out what the initial term must have been. So R is going to be 1/2. So our starting term, this is term 1. Our starting term is technically the third term. So multiply that by 1/2, we get 32. Multiply by 1/2 again, we get 16. So for our formula, the starting term is going to be 16. And then the n is 3, 4, 5, 6, 7, 8, 9, 10. So 8. Remember, it's always one more than the subtraction would be. So we've got all those values, definitely geometric. So we have S sub 8 is equal to the start of this series. So not actually A1, but just where you're starting in the series, which would be the third term, and that's 16. 1 minus R to the nth over 1 minus R. Okay, so we get 255 over 8, or if you prefer, 31.875. Okay, one more of these. This one's going to be arithmetic as well. You can just see based on the pattern here. So we're starting with the 6th value, So just pretend, remember, like A1 is just the one that we are starting with. It's not necessarily the very first value if you were to plug in a 1, but the one that we are starting with is what you'd get if you plug in a 6. So if you sub in a 6 here, times 2 is 12, minus 38 would be a negative 26. And then we do 6 all the way up to 39. So 39 minus 6 is 33. So that must mean that there are 34 total terms here. So plug the 34 in. 34 times 2 is 68. Minus 38 would be 30. And then, as I mentioned, the n is 34. So this quantity that I'm looking for, we start with the n on the outside. The first term in this series plus the last term in this series over 2. Okay, so this we've got positive 4 divided by 2 is 2. 34 times 2 is 68. All right, now for this next set, we're looking at whether a series is convergent or divergent. Pretty easy to see. If it's geometric, the ratio is smaller than 1, or in between -1 and +1, I should say, then it converges, and you can find the sum. If the ratio is bigger than 1, then it diverges, and you can't find the sum. So you could just divide these out. So this one, 3/4 divided by -3/2. You end up with -1/2. So the ratio is -1/2, which has a smaller value than 1. So that means that it converges. And then we can find the sum. So that is just all the way up this formula right here. So just A1 divided by 1 minus R. Okay, so A1 divided by 1 minus R. And that just gets subbed in. So this actually ends up being a +3/2. So -3/2 divided by +3/2, which ends up being a -1. This one, common ratio, 6 divided by 24 is 1/4. So is this, so is this. So your ratio is 1/4. That value is also smaller than 1, so this series will converge, and we can use the very same formula. So A1 over 1 minus R. Okay, and that gets us 32. Let's look at the next page. Okay, so we've got a few more. We were doing almost the exact same thing, just is it convergent or divergent? So this first one, 16 divided by 4, 64 divided by 16. The ratio ends up being 4, which is a bigger value than 1. So that means that it diverges, and you can't actually find the sum if it diverges, because there is none. It just keeps going towards infinity. This one, if you divide this out, 300 divided by 500, get a -3/5. Is that sum? It's always a good idea to just double check each one. So this value is smaller than 1. So this one converges. So our sum is A1 divided by 1 minus R. Okay, so I get 625 divided by 2, or 312.5. Number 50, we've got a geometric sequence just written in a slightly different manner, but we can see here the R just stares right at you if you're in this format. So we've got 4/5, which has a value that is smaller than 1, and so that means that it converges. So same exact formula. This one's starting with 1, so we know that A1 is 9 over 1 minus the rate. So this one, you've got 9 over 1/5. So 9 divided by 1/5 is the same as 9 times 5, and that's 45. This one, our ratio, is the one with the exponent, so that is -4/3. That value is bigger than 1, so that means our sequence diverges and we can't find the sum. Two more of these. 52 in parentheses here, you can see the common ratio is 1/3. So that means that these series will converge. This one's a little bit trickier because your lower value is a 4. So you have to start somewhere different and make sure you can kind of trace your way backwards to figure out what A1 would be. So A1, you can do this formula where you say you've got -54 and then 1/3 to the 4 minus 1. Okay, so this is the actual A1. We want to know what our starting value is starting at n equals 4. So you sub in here and we can figure out what this starting value would be. So this would be 1/3 to the 3rd power, that's 1/27th, and then times -54. All right, so we've got -2 for that value. Okay, so -2. So that's this one right here. So I can show you, like the very first one would be -54, and then you multiply that by 1/3. So that's the second term. That's the third term. And that's the fourth term. So the fourth term is where we actually want to start our sum here. Okay, so we're starting our sum with a value of -2. So that's the one that's going to sub into our formula right here. So we're starting our sum at -2 and then over 1 minus r. Okay, so -2 divided by 2/3, which is the same as -2 times 3/2. That would be a -3. Okay, 53, one more of these. We can see our ratio right in the middle here is a -1/2. That value is smaller than 1, so we know that our series converges. And so we have to kind of trace forward a little bit to see what the fifth one would be. So our first value is this -9/2, and then we figure out, so I can even show you just what the calculator would look like. So we start with -9/2. That's the first term in the sequence. We want to start with the fifth term in the sequence. So times -1/2. This is the second term, third term, fourth term, fifth term. So our actual starting term is -9/32. So the starting term that we want to use for this series, the one that starts at 5, is that value right there. So we can sub that into our formula. So starting value for this sequence over 1 minus r. Okay, so we get this lovely value right here, or we could do it in fraction form, which looks a little neater, -3/16.